Hi everyone, Krishna this side, and in this video I just want to cover the topological sort algorithm. So it's another graph algorithm which I'll be covering here in this video, and I'll use BFS approach to write the code and explain the code accordingly. And DFS approach I'll be covering next video. So what is topological sort, right? So let's just imagine if we are planning tasks that depend on each other, like we can't cook until we buy the groceries, right? And also, like we can't paint a house before building the walls, right? So this kind of what comes before what problem can be shown using directed acyclic graph. Okay, so topological sort helps us figure out a valid order to complete those tasks. Okay, so where it is used, right? So it basically used in task scheduling. Okay, so what to do first, next, and the last kind of thing. So course planning, even build a system like compilers decide which files to compile first, right? So there also it kind of basically get used. So if we have a problem such as must happen before relationship and no cycles in there, so topological sort will be getting used. Remember that this basically works in a cycling graph. So if there is any cycle we have in a graph, directed edges of the graph, then this algorithm won't work there. Okay, because our dependencies, the first thing is like we are focusing on the edges or the task that needs to be get finished earlier before considering any another task. Okay, so if we look into this first example, if I want to complete zero, before zero I need to complete first, second, third task, because these directed edges are showing that zero, if we want to complete zero, we must complete one, two, and three. The order may be anyway, there is no dependency because there are no edges, right? Like if there is any edge between 1 and 2, then we should first finish one, then only we can approach to two. But there is no edges, so we can consider any of them first. But all this needs to be finished first, then only we can consider the zero. So here they are showing also, right? We can consider any order and we can return the answer. Even here, if we look from 5, there are two edges that are going to 0 and 2. So to finish 0 or 2, we must finish 5 first. Even to finish 0, we should finish 5 or 4 before. Okay, and for 1, 4 must be finished. For 3, 2 or 1 needs to be finished. So these are some of the orders which we can return. So 4 should be first, 5 or 4, anything that we can consider here. Okay, because there is no edges between them, so there is no compulsion that we need to consider any big or small number. Okay, so this is something what we should aware of. So there is no dependency, so we can consider any of them, but we must finish 5 and 4 to look into this 0. Okay, that's the constraint here. So let's write the code in the BFS approach, and I'll explain you like what BFS, how we can approach to the BFS code, and then I'll start writing a code as well. Okay, so see, for the BFS, it is also known as Kahn's algorithm. Okay, I don't remember exactly what the name is, but I hardly remember that it is Kahn's algorithm, I guess. But anyway, let's look into the code. Okay, so see, to finish 0, I must finish 1, 2, 3, right? So what we can do is we can maintain array where any of these nodes that are there, right? So vertices that we have, these vertices in degree is something what we will consider. So for 1, the in degree is 0 because there are no any edges that are coming to 1, right? So that way we can understand that if there are no edges, then we can consider those nodes or edges, sorry, those vertices first, and then we can look for the adjacent vertices that are there, so the edges that are directed to from those nodes. Okay, so first thing is we will create another an array which is holding the in degrees of all these vertices that are there. So here for this particular example, in degree of 1 is 0, 2 is 0, 3 is 0, but for this 0 node vertices that we have, its in degree is 3 because 3 edges are directed for this one. So what we can do is, so we consider all those in degrees. So any vertices that we have whose in degrees are 0, those we can keep it inside a queue. For the BFS, definitely we basically rely on the queues, and for DFS we rely on the stacks. Okay, this basic understanding we all should have. So the nodes which has in degrees as 0, those nodes we will put it into the queue, and we start traversing for all those nodes. Okay, and we check for we can put them into the answer, whatever the answer that we need to return, because any order we can return, right? So even one we can schedule first, two we can schedule first, or three we can schedule. Here also it is showing, right? So any of them we can consider that whichever appears first from the queue, that we can consider, because all of these having in degrees as 0, right? So those nodes, any of them that is available at the top, that we can pick from, pull from the queue, and we start exploring their adjacent nodes. And for those adjacent nodes, we basically can check what is we can reduce their in degrees. Okay, because from the, let us suppose if I got 3 from the queue first, I'll check its adjacent nodes. For 3, what are the adjacent nodes? Only 0 is the adjacent node right here, because there is only one directed edge from the 3. So what we can do is, for now, for the 0, whatever the in degree was there, right? So initially it was 3, because 3 edges are pointing to 0. This particular edge we can remove, because we just explore this one, right? So once we remove this, we can reduce the in degree of this 0 as well. Now in degree is going to be 2. Now let us suppose from the queue, 1 is getting pulled. Okay, because all of them have in degree as 0, right? So any one of them will get out from the queue. So let us suppose now 1 gets pulled out from the queue. So we start exploring the adjacent nodes that are there for the 1. So adjacent node is actually 0. Vertices also we can say name them. So adjacent vertex for the 1 is 0. So again this end degree was now 2, which once as we explored this particular one, we just remove that and update the end degree for this one. So at once this is also done, we look q has 2 left out, so that also get pulled out, and we explore the adjacent nodes for the 2. And for this particular 0, now the in degree is 0. The moment we get any nodes in degree 0, we will add it into the queue. The and once this 0 also get added into the queue, we again check, since we are running inside a while loop, we are keep on checking if until the queue is empty. We keep on checking that, popping out the nodes that are available in the queue. So we pop out the 0 from the queue at last, and there is no adjacent edges or vertices that are there from the 0. So simply that will be getting added into the answers list, and that is something what we need to return. So this is all how this algorithm basically work. Let me start writing the code. So before writing the code, let's see, these are the edges that we have given, and if I'm not wrong, these edges are saying that from 3, uh, from the directories U to V, vertices U comes from V in the ordering. Okay, from 3 to 0 there is edge, from 1 to 0 there is edge, from 2 to 0 there is edge. So what I'll do is I'll just create a addition list. Okay, because we definitely need to explore the adjacent nodes, and this particular edge won't going to help us. Okay, so let me quickly create that new array list. Okay, and we have these many vertices. For int I equals 0, I less than v, I plus plus. Let's create the objects. Okay, this is done. Now from this edge graph that we have given, uh, what we can do is, we can simply get the node edge of 0, and we will be adding where it is pointing, right? So the addition node for 3 is 0, right? So from 3 it is pointing to 0, so edge of 1. Okay, so we simply created the addition list for us. This will basically help us to write the code much easier way. Okay, now once we do that, as I said, we need to create an in degree array, uh, new int v, and by default all will be having 0 values. So what I'll do is I'll just uh, explore there. For that, we need to get the array list of integer list from the ADJ. And again, we need to run a for loop to get their adjacent nodes, ADJ node for this list. Okay, and these ADJ nodes that are there, adjacent nodes, which we have, these nodes will be getting considered with what, right? So that is the question. What I have written here is we are getting the list, and these lists in degrees will be having, okay, yeah, simply these values will get considered, right? So see, I'm writing this part of code after a very long time. Okay, I remember I submitted this code in 2013 or 2023. Mm, so what I was saying is, in degree of ADJ node is something what we want to update here. So what happens is, from the list, right? So list is nothing but, as we created here, for zeroth, how many nodes are there, right? For the zero, there are no any edges that are going away from the zero. So by default, for zero, it will not come inside here, but for one, it come, and ADJ node is going to be for one, it is going to be zero. So its in degree will get updated here, and for second also it comes again here, and its zero will be there, right? So zeros in degree will get updated here. That way, for one it is 0, 2 it is 0, 3 it is 0, but for 0, all these nodes will get explode, and for this is the addition node for all of them, right? So this in degree keep on getting increased. So zeros in degree is going to be 3. So once we create the in degrees, right, what next, right? Yes, we need queue, right? So let me create a queue here, new linked list, and then inside this queue, well, okay, before going there, we need to fill the vertices which has in degrees of 0, right? So what I'll do is int I equals 0, I less than v, I plus plus q dot, let's check if in degree of I is equals 0, q dot add this particular node. Now we can check loop to this queue while not q dot is empty, while not q dot q is empty. Basically, let's pull the current vertices that is there, that is q dot pull, and let's add this into the array list, as we are asking them, they are asking us to return the array list, right? Let me create a list as well. Integer list equals new array list. This is something what we need to return. So in the list, whatever the element that is there into the queue which has an degrees of 0, that we will add it into the queue. And let's explore its adjacent nodes. ADJ node of ADJ dot get current, and let's reduce its in degree of ADJ node minus minus, and check if in degree of ADJ node equals 0. Simply put it into the queue, ADJ node. Okay, yeah, we put this thing into the queue, and yeah, basically that's it. I guess we don't need to do anything else. Just return this list. Okay, run it, and yeah, it is working fine. Okay, so this is how we use BFS approach to write the code. I'll cover the DFS algorithm in next video, and I hope you got some understanding from this. So yeah, that's all from this video. Bye bye.